Hi guys, so today we're going to keep looking at circles. We are going to look at what are known as inscribed angles, and then we're also going to look at what are known as tangents. So this first video is going to focus on the inscribed angles. So let's start sort of with a definition. Okay, an inscribed angle is an angle that has its vertex on the circle and its sides as chords. So it's going to look something like this. So in the previous lesson, we looked at central angles where this vertex was on this center point and we used a radius to make the angle. Now that we're sort of pulling that vertex back to the circle itself, what we're looking at are chords, right? Those endpoints are on the circle. It also creates arcs just like central angles did. So AC is considered the intercepted arc of angle ABC. Intercepted arc is going to get used. Really, it just means what's the arc that it opens up and creates. If you think of this like a Pac-Man, right? What's the arc that it would sort of close its mouth and eat? That's what we're looking at. If you have an inscribed angle, then the measure is 1/2 the measure of the intercepted arc. So for example, if I say this is angle X, it's creating arc that has a measure of n degrees. X is equal to 1/2 of n. So if n out here is 80 degrees, I could divide it by 2, and I know then the angle is only 40 degrees. It would work in reverse, right? If I knew the angle, I would multiply by 2 to get back out to the arc. So that relationship between the angle size and the arc size is something we're going to be putting to use. You can actually have an entire quadrilateral inside a circle. So I'm going to actually show the picture on this one first. When I say there's a quadrilateral, I mean it just as something that has 4 sides. It is not specifically, say, a rectangle or a square. It just means that I have these 4 points on my circle that get connected, and therefore it creates something with 4 sides on the inside. Okay? Opposite angles are going to be supplementary. So remember, supplementary means things are adding to 180 degrees. Opposite angles, we're literally looking at the angles that are opposite of each other. So I did use single letters here. Think of them as being the angles of just the quadrilateral, not necessarily all of these kind of weird bits and pieces that are happening. So if we're just talking about the quadrilateral, angle A and angle C are opposite. So together they have to make 180. Angle B and angle D are opposite. Same, they would have to make 180. What that means is if I know that angle 1 is 100 degrees, I know angle C has to be 80 degrees, for example, even if I don't know the arcs that are going around the outside. Okay? So we're going to take this idea of our inscribed angles and we're going to put it to some use. Okay? So these pictures might look a little confusing. My best suggestion to you is going to be, once you locate what they want you to find, follow the lines, and if need be, sort of make little markings on your picture. Okay, so they want us to find W, X, Y, and Z. So first thing I'm going to do is I'm just going to sort of set up, okay, W can equal Y, oops, missed X, and Z, right? That way, as we find things, I can sort of just come back over here and fill some stuff in, okay? So I'm going to try and find them in order. If it doesn't work, it doesn't work. It doesn't matter. So here's W right here. So notice it's in this angle. So what I'm going to do, I'm just going to follow the side up and sort of make a marking. I'm going to follow the side up and sort of just make a marking. And sometimes those little markings help because now I can see that angle W is opening up and it's making this 110 degree arc. Well, this is an inscribed angle, and that means it is half of the arc that it makes. So if my arc is 110, that means I need to divide it by 2, or I could say 1/2 times 110, either way. But if I divide it by 2, then that means angle W is 55 degrees. Okay? And so what I would do, I'm just going to sort of take those markings back off my picture so that then I can repeat the process for something else. So here's angle X. Angle X opens, goes here. Angle X opens, goes here. So notice angle X is making the exact same 110-degree arc, and that happens. You can have angles in different places, but where those chords go happen to share points. So they actually make the same arc, which means I can literally take what we just wrote and I can literally copy and paste it right below. I could have just said X equals 55. I already did the math, but it is for the same reasons. Okay, so if I then go for angle Y, here's Y. So the top line comes out here, the bottom goes to here. So it's making this 70-degree arc. So 70 divided by 2 is going to make a 35-degree angle. And then angle Z is here. It's going to come out actually at this same point, but the other side is going to come out here. And so Z is this 78-degree angle, or arc, excuse me. And so half of that arc would be 39 degrees. They could have asked me for arc measures here, in which case they would have had to have provided me an angle somewhere, and I would have simply taken that angle multiplied by 2, and that would provide me an arc measure, just to be clear. Let's look at one that has a quadrilateral on the inside. So again, I'm just going to sort of set up W, X, Y, and Z. So that then I can come over here and put my work as I need to. So again, I can start with these in order. I can start anywhere I want. If I start with W, here's W. So I'm going to follow my sides again. W comes out here and W comes out here. So it makes this whole big thing. I know this piece is 68. I don't know what this piece is. So I have two options. I can either find what this empty section is, which you can do because a whole circle is supposed to be 360. Or I can say, all right, well, maybe I don't find W first. Let's try something else. So I'm going to go with that option. Let's try something else. So X is supposed to come next. So let's try X. Here's X. It comes out here, comes out here. So I need all of this. So what you notice is this actually is using both of these pieces, the 94 and the 68. Okay, so if I take 94 plus 68, okay, I'm then going to have to divide that by 2. Okay, I have to put those two arcs together first, then I can divide. So 94 and 68 put together is 162. When I divide by 2, that's going to have a measure of 81. Okay. So now if I go for angle Y, I can follow my sides for Y, but Y is going to have the same problem with this empty section. However, angle X and angle Y are opposites of each other. And one of the things that we have looked at is that those opposite angles in a quadrilateral add to 180 degrees. So I can say 180 minus the 81 we just got for angle X is going to give me a 99-degree angle for Y. If I follow my sides to find Z, Z is here and here. So Z is going to use the 94 and the 76 in this case. And so again, we're just going to take those and divide them by 2. So putting them together, you get 170. Dividing by 2 would give me an angle of 85. And so now I can go back up to W. Just like X and Y were opposites, Z and W are opposites. So now that I know what angle Z is, I can do 180 minus the 85, and I can get a 95-degree angle for W. Had you found the empty piece of your circle, you'd end up with all of the same measures. So it is just a matter of sort of preference. I wanted to purposely use the opposite angles so that you could see how that could work. But you are allowed to simply find all the arcs when you're able to do that as well.